Hello everyone, welcome back to my channel. So in this video we will learn about Taylor's series. Okay, so Taylor series expansion, right, and Maclaurin series also. Along with that we'll solve 2 or 3 problems based on this Taylor series in this video, right? If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. Okay, so Taylor series expansion, the Taylor's series expansion of a function f of z at a point z0 is given by, so this is given by f of z is equal to f of z0 plus z minus z0 by 1 factorial into f dash of z0 plus z minus z0 whole square by 2 factorial into f double dash of z0 plus z minus z0 whole cube by 3 factorial into f triple dash of z0 plus so on. Okay, so it is infinite series, right? So this is the formula for Taylor series. Okay, so at a point z is equal to z0, very important point, right? So the ROC of Taylor's series is modulus of z minus z0 is less than r. So where r is, so z0 we know, z0 is the point at which we are finding the Taylor series. Okay, so z0 is the point at which we are finding the Taylor series. Only r we don't know, so that r is the distance. R is the distance from center of power series, that is z0 value, z0 to its nearest singular point, Okay, so this is the value of r. Suppose if you have f of z is equal to z by z minus 1 into z minus 2. So singular points here are z is equal to 1 comma 2, the z singular points. And if you are expanding in Taylor series about z is equal to 1, okay, about z is equal to 1, so this z will be z0, and what is the distance between these 2 points, that is z0 and singular points, that is what I have written here. So r is the distance from center of power series, that is z0, to its nearest singular point. So first of all you have to find the difference between them. So z0 minus, so suppose if you want you can take this as z1 and this as z2. Okay, singular points z1 and z2. So first you have to find modulus of z minus z1, modulus of z0 minus z2. So this becomes your r1 and this is your r2, right? So it will be 1 minus 1, so 0 for z is equal to 1. I am talking for z is equal to 1, so z0 is 1 and z1 is also 1, so r is equal to 0. So next z0 minus z2 is z0 is 1 and z2 is 2, so it will be 1. Okay, so r, the minimum value of r is 0, so the ROC will become modulus of z minus 1 is less than 0. Modulus of z minus z0 is less than r, where r is the distance, minimum distance from the center of series to its nearest, there is a word called nearest singular point. Nearest means minimum distance only. Okay, in this case it will be the ROC of this given f of z. Okay, so this is how we can find the ROC of a Taylor series, right? So when z0 is equal to 0, when z0 is equal to 0, then what will happen to Taylor series f of z? So what does this equation reduces to? F of z is equal to f of 0 plus z by 1 factorial into f dash of 0 plus z square by 2 factorial into f double dash of 0, because z0 is equal to 0, plus z cube by 3 factorial into f triple dash of 0, plus so on up to infinite terms. So this series is called as Maclaurins series. Maclaurins series. Okay, so when z0 is equal to 0, if you substitute z0 is equal to 0 in the Taylor series, it will become Maclaurins series. Okay, so this is how we can find a this is how we can expand a function f of z about the point z0 by using Taylor series. Okay, so we'll see some problems, then you'll understand very clearly how to find the Taylor series for a given function f of z. Okay, so next we'll solve a problem on this Taylor series. So expand e power z about z is equal to 1 he has given. So z0 is equal to 1 he has given, and f of z is equal to e power z. Okay, so Taylor series expansion, I will write the formula once again. So it is f of z0 plus z minus z0 by 1 factorial into f dash of z0 plus z minus z0 whole square by 2 factorial into f double dash of z0 plus z minus z0 whole cube by 3 factorial into f triple dash of z0, and so on. Okay, so f of z is equal to e power z, and we have to find the value of f of z0, that is f of 1. So just substitute z is equal to 1 here, so it will be e power 1, which is equal to e. Similarly, what is f of f dash of z? F dash of z is also e power z, because differentiation of e power z with respect to z is e power z only, and here also f dash of 1 is e power 1, which is equal to e. Similarly, f double dash of z is also e power z, so f double dash of 1 is also e, and so on, right? So every value is also same. F triple dash of 1 is also e, and so on. Okay, so if you substitute here, so what will happen? F of z is equal to f of z0. F of z0 value is e plus z minus z0. Z minus z0 is 1. Okay, so z0 value is 1. Z minus 1 by 1 factorial into e plus z minus 1 whole square by 2 factorial into e, because f double dash of z0 value is also e, plus z minus 1 whole cube by 3 factorial into e, plus so on. So if you take e common, what you'll get? 1 plus z minus 1 by 1 factorial plus z minus 1 whole square by 2 factorial plus z minus 1 whole cube by 3 factorial, plus so on. Okay, so this is f of z, that is expansion of e power z at z is equal to 1. So if you observe, you will get only terms z minus 1, z minus 1, z minus 1 only, because z0 is equal to 1. So z minus z0 is z minus 1. Okay, so this is the expansion. So if you talk about ROC, what is ROC? So this expansion is valid only when z minus 1 is a finite value. Okay, if z minus 1 is an infinite value, this becomes infinite, right? So mod z minus 1 is less than infinity. Mod z minus 1 is less than infinity, then only this function f of z is a valid function. Okay, so this is how we can find the ROC. Sorry, this is how we can find the ROC, and this is how we can find the expansion of f of z about a given point z0 is equal to 1 for the function e power z. Okay, right, next we'll see one more problem on this, right? So the given function f of z is sin z, and you're asked to find the expansion of Taylor series about the point z is equal to pi by 4, that is z0 is equal to pi by 4 and f of z is equal to sine z. So what is the Taylor series expansion formula? F of z0 plus z minus z0 by 1 factorial into f dash of z0 plus z minus z0 whole square by 2 factorial into f double dash of z0 plus z minus z0 whole cube by 3 factorial into f triple dash of z0 plus so on. Okay, so here z0 is pi by 4 and f of z is sine z. So we'll find the values now. F of z0 means f of pi by 4, f of pi by 4. So substitute z is equal to pi by 4 in sine z, so it will be sine pi by 4. Okay, z is equal to pi by 4 in f of z, so it will be 1 by root 2. F dash of z0, f dash of z0 is cos z, so cos z at z is equal to pi by 4, that is equal to cos pi by 4. Cos pi by 4 is 1 by root 2. Next, f double dash of z0, f double dash of z0 is cos z, differentiation is minus sine z. Okay, so that is minus sine pi by 4, minus sine pi by 4 is minus 1 by root 2. Okay, next if you want to find triple dash, f triple dash of z0 is minus cos z, so it is minus cos pi by 4, which is equal to minus 1 by root 2 and so on. Okay, it continues, right? So f of z is given by f of z0, so f of z0 is 1 by root 2, so f of z0 is 1 by root 2 plus z minus z0 by 1 factorial, z0 is pi by 4, right? So z0 is pi by 4, z minus z0 by 1 factorial into f dash of z0, f dash of z0 is again 1 by root 2 plus z minus z0 whole square by 2 factorial, right, into f double dash of z0 is minus 1 by root 2 plus z minus z0 whole cube by 3 factorial into f triple dash of z0 is again minus 1 by root 2 plus so on. Okay, so you can take 1 by root 2 as constant. Okay, you can take it out, 1 plus z minus pi by 4 plus, sorry, you'll get a minus sign here, minus, because it is minus into plus becomes minus, so minus z minus pi by 4 whole square by 2 factorial minus z minus pi by 4 whole cube by 3 factorial plus so on. Okay, this is the expansion of f of z at z is equal to pi by 4. Okay.